So today we're going to continue on doing stoichiometry problems, but we're going to bring in a new definition to apply called the limiting reactant or reagent. Before we get started with this, a quick reminder of upcoming. So today is Wednesday. When I'm making this video, it'll also be posted on a Wednesday, so you have 1 week until the next exam is due. So this is the last topic of this chapter. So on Sunday, what is due is chapter 4C, questions and discussion, and it's on stoichiometry, limiting reagents, reactants, and then percent yield, which is another topic we'll cover today. So that's due Sunday by midnight, those questions. On Sunday, the exam will open for those of you who want to take it early. So it'll be open and available to you on Sunday, but it closes on Wednesday at midnight. So make sure you're taking it before Wednesday. I have a practice exam with a key posted. I have a quick practice quiz on stoichiometry, because this is usually the hardest topic, with a few problems just like you'll see on the exam, like the same format, different numbers. So you can get practice and see what that's going to look like, so you're not surprised when you get to the exam. So take use of those. For the exam itself, and I'll talk more about this in Friday's video, it has 28 questions and a 2-hour time limit. But I'll go over more specifics and example problems in the next video. I also want to mention reading the discussion boards and having some feedback from students in classes and via email. Some people have been having difficulty with the homework questions through McGraw-Hill, through that Connect program. Not necessarily the difficulty of the problems, but entering the answers, the formatting. And I don't want people to get questions wrong, students to get questions wrong, because the format wasn't correct. So what I'm going to do for the next chapter is, instead of assigning from Connect, from the publisher, I'm going to make, well, I have already made it, I'm going to make a quiz much like the exams are. So I'll be doing that for the next chapter, probably the next 2 chapters. Give me your feedback. Let me know if you prefer my homemade quizzes, or if you want me to go back and give you the publisher's Connect homework. And I know I call them quizzes. They're going to be multiple choice and fill in the blank. It's just like your other homework assignments from Connect, in the sense that you have 3 attempts to get it done. I'll give you, if you get it wrong, you'll get a little feedback trying to help you, guide you to the right solution. The only problem when I make them is I don't have all the options that the publisher does. I can't give you a guided solution. You can't check your answer before you submit it, and all of those things. So there might be some positives, because the formatting is going to be easier with my quiz, but it doesn't have all the bells and whistles that the publisher has. So once you take that quiz, and it's not this week that I'm doing that, it's after this next exam, give me feedback on those and let me know what you prefer. But more about that next week. Let's come back to focus on chapter 4 and this next upcoming exam. So, looking at limiting reactants and reagents, what is the definition? What does that mean? Well, it's the first reactant that is used up. And when that reactant is used up, the reaction comes to a stop. If you've watched my other limiting reactant video that has been posted this whole week, I start by giving you an example, like a recipe. Because if you look at a chemical equation, you have reactants coming together and making the products. So this is kind of like a recipe. The reactants would be the ingredients. So if you're going to make something, whether it be a recipe for pancakes, cookies, muffins, or a sandwich, doesn't matter. Your ingredients are going to be over here. And the product, what you're making, what comes out of the oven, or once you're done making that sandwich, that's the same as the product. So limiting reactant is which one of the ingredients is going to run out first. Because the ingredient that runs out first, that's going to determine how much product, how many sandwiches you make. So that's what we're trying to figure out, but using a chemical reaction. We're looking at the 2 reactants, the 2 ingredients, and we're going to test, okay, how much product can I make if I use all of this reactant? And then how much product would I make if I used all of the second reactant? And whichever reactant makes less, that's limiting. Because once that ingredient runs out, we can't make any more product. The reaction stops. So, how would this look in question form? Well, first off, you would be given a balanced chemical equation, just like with our stoichiometry problems from the last video. The question might ask something like this. If 9.5 grams of oxygen, right here, reacted with 7.2 grams of aluminum, how many grams of product would form? It goes on to ask, which is the limiting reactant? Okay, well, here's a guided approach for limiting reactant problems. So I've also had some feedback from students that all of these problems, it gets confusing where to start. So I'm going to try to give you a systematic way to approach these problems that you can apply to any limiting reactant problem. So you might want to write this guided approach down, because then when you're given a limiting reactant problem, you can go back and say, okay, where do I start? All right, so the first thing you want to do when approaching a limiting reactant problem, first off, check and make sure, because you need a balanced chemical equation. And that's what this is up here. Make sure that you have that, because you're going to need it. Also make sure that it's balanced, and most of the time it'll be balanced for you, but you want to check and make sure. Why do you need a balanced equation? Because for stoichiometry, and that's what we're applying to this problem, the coefficients being the numbers in front of every element in compound, the coefficients represent the number of moles. And when we're going between two different atoms or elements, we need it in mole form so that we can use those coefficients to compare them. Okay? So coefficients represent the number of moles. Next, once you have that balanced chemical equation, then you're going to take each reactant separately. So it's going to be two different calculation setups. Each reactant separately and calculate. Ask yourself this question. If I used all of this reactant, how much product would form? Okay, so how does this step look? Well, I'm going to apply it to this one. So the question I would ask myself is, I'm going to take each reactant separately. So what are my two reactants? Oxygen, aluminum. So I'm going to take each separately. So I'm just going to start with oxygen, since that's the first one they give me in the question. And what I'm going to ask myself, I'm going to say, if I used all of that 9.5 grams of oxygen, I used all of it, how much product would form? Okay, so I'm asking how much, question mark, product, and the product is, in this case, aluminum oxide. So how much aluminum oxide would form? So this is what I'm trying to solve for. I'm going from oxygen, using all of that, how much product? Now notice it says, take each reactant. So this is just one of the two reactants. So I need to do this same step for both reactants. So next I look at aluminum, and the amount given for aluminum, my other reactant, is 7.2 grams. I'm going to ask myself, if I used all 7.2 grams of that aluminum, how many grams of product would I form? All right, so the third step then, and we're going to solve these in a minute, but once these are solved, because I want to give you all the steps in one spot, the answer to the limiting reactant is the reactant that forms the least product. So once I solve for these two, it's going to be whichever one has a smaller amount of product made, a smaller gram amount of that aluminum oxide made. All right, so I'm going to erase these steps. So if you haven't written them down, write them down now, and then we'll solve this. We'll do the calculations going from grams of oxygen to grams of aluminum oxide, and then from grams of aluminum to grams of aluminum oxide.